Hi students, I'm continuing the chapter sets and today I'm going to discuss some problems related to sets chapter. So listen carefully. This is our next question. In this question we need to show that A union B equal to A intersection B implies A equal to B. So let us start the solution of this question. First let us consider small letter A is an element of capital letter A. Then we can write as A is an element of A union B. We know that A union B is the set which consists of all the elements of A and all the elements of B. So we can easily write it as A is an element of A union B. Since given that A union B equal to A intersection B, so we can write it as A is an element of A intersection B too. That means we know that the A intersection B means the elements which are common to both A and B. So we can write it as A is an element of A intersection B. So A is also an element of A intersection B. Okay. Next is an element of, A is also an element of B. Because A is an element of A intersection B. Intersection means the elements which are common to both A and B. So A is included in the set A intersection B. So A is also element of B. Okay. Therefore, we can write it as A is a subset of B. Subset means if every element of A is also element of B. Okay. Similarly, let us consider if B is an element of small letter B is an element of capital letter B, then we can write it as B is an element of A union B. Union means both the set consists of all the elements of A and all the elements of B. Okay, since given that A union B is equal to A intersection B, so B is also an element of A intersection B, right? Intersection means the elements which are common to both A and B. So we can write it as B is also an element of A. Therefore, we get B is a subset of A. If every element of B is also element of A. Thus, we can, if we get both A subset of B and B subset of A, so we can write as A. Therefore, A is equal to B. Both the elements in the sets A and B are equal. So, we write as A equal to B. Hence, proved. Okay, I hope you understood. This is our next question. For any set A and B, we need to show that P of A intersection B equal to P of A intersection P of B. Here, P represents, we know, I hope you remember the concept power set. What is power set? The collection of all subset of set is called power set. So, here, power set of A intersection B equal to, we need to show that power set of A intersection B equal to power set of A intersection power set of B. Okay, so let's start the solution of this question. First, let us assume A equal to a set containing elements 1, 2, 3, and B is a set containing elements 1, 3, 5. Next I am going to find out A intersection B. Intersection means the elements which are common to both set A and B. So let us observe these two sets here 1 and 3 are common. So the A intersection B answer will be 1, set containing elements 1, 3. Okay. Here next we need to find P of A. That means power set of A. P of A equal to we need to write all the collection of subset. So subset starting from null set. First next one is singleton set 1, 2, 3. Next element the set which containing two elements 1, 2, 2, 3 and 1, 3. Last one is our set A itself 1, 2, 3. Okay. P of A equal to we get P of A equal to null set 1 singleton set 1, 2, 3 and set containing two elements 1, 2, 2, 3, 1, 3 and the last the set A itself. Okay. Next we need to find P of B. So starting with the null set. Next we write the singleton set 1, 3, 5. Next set containing two elements. So starting with 1, 3, 3, 5 and 1, 5. Last one is our set B itself 1, 3, 5. Okay. Next I am going to find power set of A intersection B. So starting with the null set P of A intersection B equal to null set. Next one is singleton set containing 1. Next set is singleton set containing element 3 and last one is the A intersection B itself. That means element containing 1, 3. Okay. So let us name it as equation number 1. Next I am going to find out the RHS. That means P of A intersection P of B. Power set of A intersection power set of B. We need to find out the elements which are common to both P of A and P of B. So let us observe these two sets. The elements which are common will be, first one is null set. Second one is the singleton set containing 1 is common in both P of A and P of B. Third one is 3, right? A singleton set which containing element 3. Last one is comparing these two 1, 3. The set which containing elements 1, 3 is also common in both P of A and P of B. Okay. So let us name it as equation number 2. So if you observe equation number 1 and equation number 2, both are equal, right? So we can write it as equation number 1 equal to equation number 2. So we found P of A intersection B equal to P of A intersection P of B. Power set of A intersection B equal to power set of A intersection power set of B. Hence, proved. I hope you understood. This is our first question. In a group of 65 people who like cricket, 40 like cricket, 10 like both cricket and tennis. How many like tennis only but not cricket? How many like tennis? So here we need to find out two answers. First one is those people who likes tennis only but not cricket, and second question, the people who like tennis only. Okay, so let's start the solution of this question. Given first, let capital letter C be the set of people who likes cricket, and T is the set of people who like tennis. Okay, so given that in a group of 65 people, that means given that n of C union T equal to 65. 40 likes cricket, that means n of C equal to 40. 10 likes both cricket and tennis, that means n of C intersection T is given as 10. So we need to find how many like tennis only but not cricket. That means we need to find out n of T minus C. This is our first question. Next, how many like tennis? And next one is we need to find n of T. Okay. So first of all, we know that the relation between union and intersection. What is the formula? N of A union B is equal to N of A plus N of B minus N of A intersection B. Replacing A by C and B by T, we get N of C union T equal to N of C plus N of T minus N of C intersection T. So, substituting the given values to this equation, we get given that N of C union T is 65, N of C is 40, N of T is not given, N of C intersection T is 10. From this we get N of T is equal to 65 minus 40 plus 10. The answer will be 65 minus 40, 25 plus 35. 25 plus 10, that is equal to 35. The number of people who likes tennis only is 35. Next question, we need to find n of next we need to find n of T minus C. That means how many people who like tennis only and not cricket. That means n of T minus C. Okay. So first of all, I am going to draw the Venn diagram of two sets. First set is C and second set is T. Okay, and this portion is, we know that this portion is intersection, C intersection T, right? C intersection T, and this portion is C minus T, and this one is T minus C. So here we need to find n of T minus C. From this Venn diagram we get the total set T is equal to the sum of T minus C portion plus intersection C intersection T portion. Right. So next I'm going to convert it into number form. So just writing n of, that means number of t. N of t is equal to n of t minus c plus n of c intersection t. Here given n of t, here n of t, we have found out it is 35. So just substituting here n of t as 35, n of t minus c is not given, and n of c intersection t is given as 10. From this we get n of t minus c equal to 35 minus 10, it will be equal to 25. So 25 people likes tennis only and not cricket. I hope you understood the whole question. This is our next question. A market research group conducted a survey of 1000 consumers and reported that 720 consumers like product A and 450 consumers like product B. What is the least number that must have liked both product? Okay, so let's start the solution of this question. Let U be the set of consumers questioned, and A is the set of consumers who like the product A. A. Okay. Product A. And B is the set of consumers who like the product B. Given that a market research group conducted a survey of 1000 consumers, that means they have given n of universal set is equal to 1000, and reported that 720 consumers like product A. That means given that n of A is equal to 720, and 450 consumers like product B. Also given n of B is equal to 450. We need to find out the least number that must have like both the product A and B. That means we need to find n of A intersection B. Note that least number that must have like both product A and B. Okay. So we know that our formula n of A union B is equal to n of A plus n of B minus n of A intersection B. Okay, and substituting the given values, we get n of A union B is equal to, substituting 720 by replacing n of A, and next the value of n of B is 450, and n of A intersection, that we need to find out the value of n of A intersection B. Okay. So let us observe, we know that n of A union B is maximum. N of A union B is maximum when n of A intersection B is least. A union B is a subset of universal set. That means if every element of A union B is also an element of universal set, that we have to set that A union B is a subset of universal set. Okay. I hope you understood. From this we can write it as n of A union B must less than or equal to n of universal set, and which is given as 1000. N of union is given as 1000. Okay. So maximum value of n of A union B, from this we can say that maximum value of n of A union B is 1000. Okay, so substituting the maximum value of n of A union B, that means it is equal to 1000 here. We get 1000 here and 720 plus 450 minus n of A intersection B. From this we get n of A intersection B equal to 170. Thus we get the least value of n of A intersection B is 170. Hence, the least number of consumer who liked both product is 170. The only thing we need to note that in this question is n of A union B must be less than or equal to n of universal set. I hope you understood the whole question. Okay. This is our next question. A college awarded 38 medals in football, 15 in basketball and 20 in cricket. If these medals went to a total of 58 men and only 3 men got medals in all the 3 sports, how many received medals in exactly 2 of the 3 sports? So let's start the solution of this question. First, let F be the set of men who receive medals in football, and B is a set of men who receive medals in basketball, and C be the set of men who received medals in cricket. Okay, so given that a college awarded 38 medals in footballs, that means n of F is equal to 38. 15 in basketball, that means n of B is equal to 15. 20 in cricket, that means n of C equal to 20. Okay. If these medals went to a total of 58, that means it is given that n of F union B union C equal to 58. And only 3 men got medals in all the 3 sports. That means n of F intersection B intersection C is equal to 3. We need to find out the people who received medals in exactly 2 of the 3 sports. Okay. So here we are going to apply the formula of three sets A, B, C. So what will be the formula of three sets? N of A union B union C is equal to N of A plus N of B plus N of C minus N of A intersection B minus N of B intersection C minus N of A intersection C plus N of A intersection B intersection C. Replacing A by F, B by B and C by C. Here C means cricket, B means basketball and F means football. So our formula become N of F union B union C equal to N of F plus N of B plus N of C minus N of F intersection B minus N of B intersection C minus N of F intersection C plus N of F intersection B intersection C. So substituting the given values here, we get N of F union B union C equal to 58 equal to N of F is given as 38, N of B as 15 and N of C as 20 minus of, here minus is common in these three terms, so taking outside we get N of F intersection B plus N of B intersection C plus N of F intersection C. The last one is N of F intersection B intersection is given as 3. From this we get N of F intersection B plus N of B intersection C plus N of F intersection C. Moving this minus term to LHS, we get positive this term and equal to 38 plus 15 plus 20 plus 3 minus 58, and which will be equal to 18. Okay, so let us name it as equation number 1. We know that this is the Venn diagram of three sets F, B and C. So here A denotes the number of men who got medals in football and basketball, and B denotes the number of men who got medals in football and cricket, and C denote the number of men who got medals in basketball and C. Last one is D. D is the number of men who got medals in all the three. So our equation number 1 is N of F intersection B plus N of F intersection C plus N of B intersection C equal to 18. So I am going to replace this N of F intersection B by A plus D. N of F intersection B. F intersection B means the portion where the men who got medals in both football and basketball. Right. So I am replacing N of F intersection B by A plus D. So this is the portion. Next one is N of F intersection C. F intersection C means the portion is here. So I'm going to write F intersection C by B plus D. Next one is n of B intersection C. So this is the portion. So I am going to write C plus D instead of n of B intersection C, which will be equal to 18. Okay. So from this we get A plus B plus C plus 3D equal to 18. A plus B plus C equal to 18 minus 3D. We know that the D portion, it is given that D equal to 3. That means D denotes the number of men who got medals in all the three. So it is given as 3. So substituting here we get 18 minus 3 into 3 equal to 9. 18 minus 9, which will be equal to 9. So A plus B plus C equal to 9. This is our final answer. We need to find the number of people who got medals in exactly 2 of the 3 sports. So A plus B plus C, which gives the number of people who got medals in exactly 2 of the 3 sports, and we get 9 people who got medals in exactly 2 of the 3 sports.